Hello everyone. So this is going to be Algebra 2's first flip lesson. We'll be covering graphing systems of equations today. So this will be your guys' first lesson on for Chapter 3 out of the book, which covers systems of equations. Chapter 2 is all about linear relationships. So it's everything that dealt with individual lines, everything of the form y equals mx plus b, and everything that we can do with it, parallel and perpendicular lines, and finding x and y intercepts. What we do with systems of equations is we have multiple lines, and we look at how, when we have multiple lines, how they interact with one another. So this is like what we would normally do in class before we try to flip lessons. So this is the regular packet that you guys would normally get in class, and you guys are going to work through it as the video plays. We're going to come back to these do now problems at another time, so you guys can skip these for the time being. This is going to be your homework assignment. This is actually the assignment along with the coursework page, which looks like, oh, do I have one here? Yes, right here. This is the coursework page, which you guys will get. I will give this to you guys in class the next time we come together. And we'll do this page, and we'll do the homework assignment all together in class. So your guys' job is to get through all the note-taking for your homework assignment. But if you want to jumpstart, this is what we will be working on next class period. Let's come back to the do now problems later. Quick graphing review for you guys. So we have our linear forms. We have ax plus by is equal to c. This is what we called our standard form. Y equals mx plus b. This is our slope-intercept form, which is predominantly what we're going to be using. And then here in Chapter 3, we're going to be graphing two lines on one graph. Very exciting. So, steps to solving a system of linear equations. So I will edit this. I'm going to be all clever about this. Okay, step number 1. When we are solving a set of linear equations is you want to put all equations in slope-intercept form. It's just a little bit easier to graph stuff in slope-intercept form, so put all equations in slope-intercept form. Okay, so that'll be our first step. Step number 2 is you want to simplify everything. So if there's anything that you can factor out of all the different terms of the equation, you want to do that. You want to put it in simplest terms. Okay, I'll show you guys an example of that a little bit later on, and you guys can work through it, and you guys will see what you can do. After that, you guys are going to graph it. Okay, that's everything we did in Chapter 2. So as you guys remember, if it's in y equals mx plus b form, we're going to plot the y-intercept. Okay, and then you guys can use the slope form, and you guys can do a staircase. Okay, alternatively, you guys can find 2 points and draw a line through them. Okay, so that's how we go about doing this. And what you're looking for specifically when you're doing this is you're looking for the point of intersection. So the point where the two lines cross is what we're ultimately looking for when we do this. Okay, so we're looking for the point of intersection. Okay, we have two ways of going about doing this. The first one we're going to do that we're doing in this video is called graphing. So you guys you'll graph the two lines, and you just physically look for where they cross each other on the coordinate plane. The other way to do it is using algebraic methods, which you guys may have seen in Algebra 1. It's known as substitution and elimination, which is what we'll hopefully be doing in our next lesson. So before the end of the week, hopefully you guys will see either substitution or elimination. We'll have a chance to work through those. Okay. All right. So let's start off with an example so you guys can see how this is done. I gave you guys some graph paper during class, or if you have your own graph paper or however you want to do this. I would strongly say, when it comes to graphing these, you guys are only going to graph these by hand when you guys are doing the homework. Later on, we'll actually take some time in class, and I'll show you guys how to do this on your calculator and how to find intersection points that way. There's actually a really simple methodology of doing that with a TI-84 that'll allow you guys to find all of your intersections and stuff. That's pretty straightforward. So for us, we are going to use, or I'm going to use, GeoGebra. So what we're going to do is we're going to graph these two lines here. So the first thing we need to do is we need to put everything y equals mx plus b form. This line is already in y equals mx plus b form, so we need to write this one in y equals mx plus b form. If you solve this for y equals mx plus b, we will get y is equal to negative 5x plus 17, just by subtracting 5x from both sides. Okay, so I'm going to enter this equation and I'm going to enter this equation into my GeoGebra app, or into my graphing calculator here, and we'll see where the intersection is. Okay. So if I take these and I plug them in, I've got y is equal to 3x minus 7. Almost. Y is equal to 3x minus 7. So there's our first line. Okay, so this is y is equal to 3x minus 7. Our second line we have here is y is equal to negative 5x plus 17. Plus 17? Haha, I knew that. That is what I have written here, right? Yes, plus 17. Okay, and we'll graph that. So we have this intersection point right here. It looks like it occurs at the point 3, 2. Now, all the problems you guys will see in the homework and which you should see in the coursework should all work out to stuff that you guys can measure fairly easily. So it'll be at either perfect intersection points or it'll be at like halfway points. We'll just use like 1/2 and stuff to check our values and stuff. In this case here, since I am using a computer here, I am going to check it here. So I'm going to look at the intersection of two objects. This is my first object. This is my second object. My intersection is at point A, and my intersection appears to occur at the point 3, 2, which matches up with my grid. So 3, 2. Yay. Cool. So that's all you guys are really going to be doing in this first homework assignment. You're going to graph two lines, and you're going to look for where they intersect with each other. Okay. We do have our methodology on how to do this. Everything slope-intercept form. Simplify everything. If we look at our two examples here, there was nothing that I can pull out of 3 and 7. Negative 5 and 17 don't have any common multiples, so there's nothing to simplify in this example. Okay. Sometimes there will be, you guys will see a couple of examples here in a minute that where you do have that ability to simplify stuff out. We are going to save this page here, the classwork review, for in class when we actually do the when we do, oh, I've lost it, where is it? Oh, when we do this PDF, when we do the in-class classwork assignment, which is these 7 problems, we'll save this. This references that page. So we'll come back to this page later. So we're going to go to the next page now. And we have what systems of equations tell you. So this is really where all the vocabulary comes into play. You have 3 different scenarios. So if I give you any 2 lines and we just throw them down, one of 3 things is going to happen. Okay? They're either going to cross at a single point. This is the majority of the situations you guys are going to be seeing. And these create exactly one solution. This is what we call the consistent and independent case. Okay. The second scenario is you have 2 parallel lines. So you drop 2 lines down and they never cross. They never cross, they never have an intersection, which means the 2 lines will never have a solution to the system. That's what we call the inconsistent system. Okay. And then we have the same line. This is the dependent scenario. You're going to see one of these in the examples here in a minute when we go through those. This is when you have the same line. So this only happens in a scenario where you didn't simplify everything. This is why I have you simplify everything. Let me give you guys an example here. Let's go back to the GHouse example page just for a second here. I'm going to come up with one. Let's say we had y is equal to 2x plus 1. Okay, but let's say that I had another line and I gave you something like 3y is equal to 6x plus 3. Okay. Now, just looking at these look like 2 different lines, but this bottom equation has every single number is a multiple of 3, so we can divide 3 out of everything, which goes back to this step here of simplifying everything. So if we simplify everything in this case, we actually end up with our same exact equation here. If you see this in standard form, which is how usually these problems will start off, is you'll end up in standard form. So in standard form, this would be would this be negative 2x plus y is equal to 1, and then the other form here would be negative 6x plus 3y is equal to 3. Okay, would have been our system. So if we had started off with these 2 equations, these don't look the same at all right now, but if you put them into y equals mx plus b form, and then you simplify everything, okay, and you simplify everything, then they end up coming back to this original form, and you'll see that what you're really looking at is a system with 2 of the same line in it. Okay. So those are our 3 possible cases that we can have: consistent, inconsistent, and the consistent, the inconsistent, and the dependent case. Okay, or independent, inconsistent, dependent. That's how I learned it when I first learned this. So, all right. So let's talk about what the solution of a system of equations is. That is going to be whatever the number is. So this is an example you guys are going to see on the classwork assignment. Let's come back to that one at another time. Let's go back to my example for a second here. So let me get rid of some of the stuff here we don't need. I'll get rid of. Hey, stop it. We're going to get rid of those two, and I'll get rid of this really quick. So when we, just a second everybody, I know. Okay, there we go. So when we graph these two, we got the solution 3, 2 when we did our graph on this last page. That's where our point was, 3, 2. Okay, so we have 3, 2. This is a solution to this system of equations. So whenever I say find the solution of the system of equations, what I'm really asking you to do is find the coordinates of the intersection. Okay, so the solution of a system of equations is the ordered pair where the two lines intersect. So it's the coordinates of the intersection. And this is an example off the classwork, and we'll come back to that one later. So let's move on to the two examples now, and we'll finish up with those. So solve the system by graphing. So first thing we're going to do, we're going to write everything in y equals mx plus b form. So let's solve the top one for y equals mx plus b. I actually want you guys to stop the video at this point. I want you guys to solve both of these equations for y. So put them into y equals mx plus b form, and then after you've found y equals mx plus b, come back to the video. I'll have the equations up here for you guys, and you guys can compare your work and see if you guys got the same answer. Okay, so go ahead and hit the pause button. Okay. All right, so you guys come back now, and the first one should come out to y is equal to negative 2x minus 7, and the second one should come up to, since we have a minus y here, it's going to be y is equal to x minus 1. Okay, so those should be your two lines. You'll take these two lines, you'll graph them in you'll graph them on graph paper. I'm going to graph these on Desmos really quick here so you guys can see it and you guys can compare your graph with what I'm generating. So I have 2x, actually I'll use the same ones you guys have. So we have y is equal to negative 2x minus 7, I believe. Yes, minus 7. And our other line was x minus 1. So y is equal to x minus 1. Graph those two lines, and it looks like we have ourselves an intersection at, looks like we have ourselves an intersection at negative 2, negative 3, which I'm going to double check here really quick. Grab this object, and our intersection is at negative 2, negative 3. Okay, so I'll put that here. The solution for this system is at negative 2, negative 3. Okay, good. All right, our example number 2 here. Again, I would like you guys to solve both of these equations for y, and then come back to the video. So go ahead and hit pause and come back to the video in just a second. All right, so you guys have come back now. You guys should have solved both of these. The second equation is already done for us. That's good. That saves us a little bit of time. Let's take a look at this equation here. When you guys solve this for y, let me see if I have some text somewhere. So if you solve it for y, I'm going to put this down here. If you solve this for y, you will end up with 8y is equal to negative 6x minus 16. Okay, so you should end up with this. We still have to solve for y. If you divide everything by 8, and then simplify, so you reduce everything into lowest terms, negative 16 divided by 8 is negative 2, and negative 6 divided by 8 is negative 3/4. So this equation here simplifies into the second equation. So this is that dependent case that we were looking at earlier, back here where we have the same line. Okay, you guys put everything y equals mx plus b form, you simplified it out, and lo and behold, you end up with the same line for both lines. So really all we can do here is just graph these, graph it and then find the x and y intercepts. In your actual homework assignment, you'll just be asked to graph it and then describe it as either consistent, as either independent, dependent, or inconsistent. And that's all that you'll have to do there. And then on the other problems, you'll be asked to solve the systems of equations by graphing, which is what we did in the previous problem. Okay. All right, that gets us through our first section here. We'll come back and we'll take a look at these problems during class. We'll do it as a bit of a warm-up activity at the very beginning of our next class, and we'll go from there. I'll see you guys in class.